In this module, we'll dive into the fascinating relationship between the aircraft lifecycle and engineering supply chain integration. Let's see how every phase, from entry into service to retirement, really impacts the way airlines manage their operations and logistics. Welcome to Module 2 of our Airline Engineering Supply Chain course. Today, we're going to explore how the aircraft lifecycle, from entry into service to retirement, directly shapes supply chain decisions and operations. We'll use real-world examples to bring this to life. Let's begin. When an aircraft is first delivered, it enters the entry into service phase. This is where the supply chain gears up to support it operationally. Think about this like setting up a support ecosystem from scratch. You're provisioning spare parts based on OEM recommendations, onboarding the aircraft's data into your ERP and MRO systems, procuring specialized tools and equipment, and ensuring your maintenance teams have access to manuals and training. For example, when Qatar Airways receives a new Airbus A350, its engineering supply chain team works with Airbus to determine the initial provisioning list. This includes hundreds of part numbers, everything from oxygen masks to flight control actuators. They also set up warranty coverage and link the aircraft serial number to the vendor database. Every minute an aircraft is not ready to fly impacts revenue, so EIS is a supply chain sprint. So this is actually the longest stage in the aircraft lifecycle. The aircraft is out there flying, every day, every week, and sometimes for many years. At this point, the supply chain's job is to make sure the aircraft stays airworthy, gets fast turnarounds, and that costs are kept under control. You need to supply parts for line maintenance, handle scheduled checks like A and C checks, and be ready to manage those unexpected AOG events. For example, let's say a plane in Jakarta suddenly has a faulty hydraulic pump. You might have to fly that part in from a pool in Frankfurt and do it within just a few hours. That's real-time logistics in action. You also have to be really smart with your inventory. Do you keep expensive parts stocked at every single outstation? Well, probably not. So you rely on data, things like usage rates, failure history, and reliability trends, to help guide your stocking decisions. Here's an example. If your records show that fuel quantity probes tend to fail pretty often after about 8,000 flight hours, you'd plan bulk purchases of those probes in advance. Maybe you'd negotiate better repair rates, or even consider switching to more reliable PMA parts. When the aircraft finally reaches the end of its economic life, or it's being phased out, the supply chain has to step in and help decommission it properly. So your job here is to make sure you comply with lease return conditions, harvest any usable parts, sell high-value items like engines or avionics, and manage all the documentation and traceability that goes along with it. So let's look at a real case. A carrier retiring its Boeing 777 fleet might decide to part out the engines and use them to support a smaller freighter fleet. The landing gear could be sent off to a teardown company for resale. Meanwhile, all those maintenance logs are carefully backed up for regulators and leasing companies. Even in retirement, the supply chain honestly still plays a vital role in value recovery. Now let's talk a bit about configuration control. Aircraft come in multiple variations, even within the same model. You'll see different avionics, engine thrust ratings, interior layouts, and so on. If your system shows the wrong part number for a component, you could actually end up grounding an aircraft just because of a simple mismatch. And traceability failure isn't just a paperwork issue. It can cost hundreds of thousands in lease penalties or regulatory findings. That's exactly why configuration control is so tightly linked to your engineering and material planning systems. Everything really needs to be aligned. AMOS, TRAX, SAP, whatever system you're using. Your maintenance planning tools absolutely must talk to your procurement systems. That's where true supply chain integration actually happens. For instance, if a C-check is due in, say, 6 months, the system should trigger long lead time parts procurement today. Or let's say predictive maintenance tools detect a pattern in engine vibration data, maybe suggesting a bearing issue. Your supply chain team can act proactively, sourcing the part before it fails. This is really where digitization plays a game-changing role. Let's look at cost. Managing the total cost of ownership, or TCO, is central to engineering supply chains. A part might be cheap to buy but expensive to install or repair. You need to factor in things like mean time between unscheduled removals, or MT bar, warranty length, repair loop turnaround, and service reliability. Some airlines are now using PMA parts, which stands for Parts Manufacturer Approval, to reduce cost, or DER repairs, Designated Engineering Representative repairs, to extend life on expensive parts. Others are buying green time engines from retired fleets instead of overhauling existing ones. These are clever strategies rooted in supply chain engineering. Service bulletins, or SBs, and airworthiness directives, or ADs, are another area where engineering and supply chain must collaborate. So SBs are issued by OEMs to recommend updates. These are often optional. But ADs, on the other hand, come from regulatory bodies and are absolutely mandatory. The supply chain's job is to quickly source kits, figure out which aircraft are impacted by serial number, and, coordinate installations with maintenance planners. If this isn't done on time, well, that means grounded aircraft or even fines. Let's recap for a moment. Aircraft move through stages: entry into service, in-service operations, and retirement. And the supply chain supports each one with the right parts, tools, contracts, and data. You're not just supporting maintenance, you're actually shaping cost, performance, and safety. An integrated, responsive engineering supply chain really makes the difference between an airline that runs smoothly and one that's constantly reacting to problems. In our next module, we'll dive into the different types of aircraft maintenance checks and how the supply chain supports each one. Here are some key takeaways. The aircraft lifecycle shapes the supply chain strategy. Integration between systems ensures proactive support, and value engineering and traceability are key to operational excellence.